Salam sejahtera, Dr. Darina. Now I will present my part, which is the introduction in this library flow in open channel. So in this experiment, we need to know that this experiment will be conducted as the two part. Part 1 as the hydraulic jump, part B as the force on a switch gate. So in this slide, we can see clearly which one is the spillway and another picture is the switch gate. So the objective in this experiment, part 1, is to investigate the characteristics of a standing wave, the hydraulic jump produced when the water beneath it and undershot wear, and to observe the flow pattern of them. In this slide, I need to explain the theory in this hydraulic jump. So as we know, a hydraulic jump is a sudden energy dissipation caused by a change from supercritical to subcritical flow. This fact may be due to the presence of some structure obstructing the movement of straw in open channel. So it means the flow of the water was obstructed by a structure. The water flow rapidly changed to slower trickle flow. Hydraulic jump occurred with a dip less than the critical, change to a dip that is greater than critical and must be accompanied by a loss of energy. A large amount of energy loss produces a zone of extremely turbulent water before it settles into a smooth tranquil flow. So in this library, the equation is important to be found out, and we need to know and understand the application of equations to solve the problem and do the data analysis. So by considering the force acting within the field on either side of a hydraulic jump of unit weight, so there is the one equation we need to know and remember. Change of the head is equal to the dA plus the VA power 2 divided 2G minus dB plus VB square divided 2G. That is the equation 1. So as we know, the change of the head is the total head loss across the jump. Energy dissipated, so the unit is meter, and VA is mean that the mean velocity before the jump. So before arrive the jump, VA is the mean velocity. So we need to convert dA equal to d1 and dB equal to d3. So we simplify this equation. Change of the head equal to d3 minus d1 power 3 divided by 4 d1 d3. So that is the simplest equation we need to apply and know. So for the part B library is the force on a switch gate. So the objective is to determine the relationship between the upstream head and thrust on a switch gate under short wear for water flowing under the switch gate. So in this slide, we can see the theory gate regulate the level and flow in open channel and reservoir. The switch gate is one of the most commonly used. To design a switch gate, it is necessary to determine the head discharge relationship and the pressure distributions over the gate. So the figure is show directly the force by the moment equation. We can see clearly the hydrostatic pressure distribution will acting on the right hand side. So there is the D1. So and the hydrostatic pressure distribution will acting on the left hand side. So for the equation in this library, the resultant force on the gate is given by the equation below. Fg equal to 1/2 Pg d1 square times the d0 square divided d1 square minus 1 minus Pg divided bd1 times the 1 divided d1 minus d1 divided d0. So Fg is equal to the resultant gate thrust, and Q is equal to the volume flow rate. The unit we use is the m per s. So the B is the breadth of the gate. D is equal to the density of fuel. So the unit we use, the density unit is the kg per m's power 3. dg is the height of the upstream opening. d0 is the upstream depth of flow. d1 is the downstream depth of flow. So the unit on both we use the in the meter m.
Next is methodology. For this experiment, we use 6 apparatus, which are flow rate meter, downstream plate adjustment, sluice gate, valve, reader hook, self-contained glass side tilting flume. Next is procedure. Number 1. The opening of the sluice gate should be set to 2.5 cm in the preparation for part A. Ensure that the downstream tilting is made similar to downstream plate. Number 3. The valve should be adjusted until the desired flow rate is reached. Number 4. Make sure to observe the water level until it is stable. Number 5. After the water has stabilized and the hydraulic jump is created and measure, record the reading for Y0, Y1 and Y3 by using reader hook. Number 6. 5 average reading for Y1 were recorded. Number 7. The same step were repeated for 5 measurements using the desired flow rate. Number 8. For part B, the opening sluice gate was made sure to be 2.4 cm. Number 9. The valve was used to increase the water level until the reading for Y0 reached 20 cm. Number 10. The reading of Y0 and Y1 were recorded similar to part A. And the last is the opening of the sluice gate were recorded with increments of 0.5 cm up to 5 measurements, and the reading for Y0 and Y1 were recorded.
Hi, Assalamualaikum Doctor. My name is Nur Ashira and I would like to present to you about the result that we got from our experiment. This is the result for case 1, which is hydraulic jump experiment. For this experiment, the manipulated variable is flow rate and our constant variable is wheel opening. For value Y0, Y1 and Y3, we got it from the experiment, and the rest of it we use the calculation for the value. This is the result for case 2, which is sluice gate experiment. For this experiment, the manipulated variable is wheel opening and our constant variable is flow rate. For value Y0 and Y1, we got it from the experiment, and the rest of it we use the calculation. This is the calculation for hydraulic jump. For total head loss, we use the formula Y2 minus Y1. This is the calculation for hydraulic jump. For total head loss, we use the formula Y3 minus Y1 cube divided by 4 multiple with Y1 and Y3. For velocity, we use V equal to Q divided by YG multiple with B, which is the weird breadth that equal to 0.3 meter. For the third equation, we want to find YC for the comparison, and we use Q power of 2 cube root and divided by G. And with the calculation that we made, we used to get the Y1 less than YC and less than Y3. This is the calculation for sluice gate experiment. For gate thrust FG and for hydrostatic thrust FH, we use the formula above. And with that, we got this kind of graph for analysis.
Okay, for the discussion, the first one is hydraulic jump. Hydraulic jump are sudden increase in the liquid surface due to the discharge of the high-speed liquid into a region with lower velocity. This process converts initial kinetic energy into the potential energy, but some energy is wasted as heat. Hydraulic shock occur when the subcritical flow turns into the supercritical flow, raising the water surface and reducing the energy burden. This is the crucial for energy dissipation in hydraulic structure like dam. In an experiment, faster water velocity shown the water spreading energy can be controlled and can be decreased to lessen dam well erosion. Larger water flow rates result in a larger depth of flow under a hydraulic jump, indicating the powerful hydraulic jump and significant energy loss. Human error in trial is common, but two people confirm in the flow height to improve data accuracy. Hydraulic jump can raise water level for integration, minimize the scoring, and dissipate the energy in water flow across the hydraulic structure. Next is the sluice gate. Understanding the force operating on the sluice gate, it involves the analyzing various variables such as a center of pressure, where the opening, average water surface position, upstream flow depth, gate thrust, and hydrostatic thrust. These elements are crucial for the formulating effective hydraulics framework and ensuring secure water management installation. Higher way opening reduce stress of the sluice gate, but the reading accuracy or measurement error can occur due to equipment calibration issue. To avoid this, operation measuring method and a routine calibration are recommended. Human error such as incorrect data interpretation or protocol discrete can also be reduced through training, procedure, and knowledgeable supervision, amplifying and fixing this mistake, increase the reliability and security of laboratory experiment.
For the conclusion flow in open channel experiment, objective achievement, successful implementation of the experiment, achievement of the expected objective, investigation focus, explore characteristic of standing wave hydraulic jump below the lower dam, hydraulic jump occurrence, sudden rise in water surface when high velocity water encounter a zone of lower velocity. Opening of the dams contributes to increased water level and velocity. Velocity increase directly proportional to the opening of the dam. Data analysis demonstrates this direct correlation. Data observation, visual representation of data obtained during the experiment clearly show the increase in velocity with corresponding change in dam opening. Constant flow rate important emphasis on maintaining a constant flow rate highlight the necessity for observing change in the hydraulic jump pattern. Result summary, key finding and achievement summarized. Successful accomplishment of the experiment objective.